All right, well, we're going to go ahead and get started. Welcome, everybody. It's great to see you all here this evening. Thank you for taking time to spend a little time talking about teaching through change in the STEM classroom. My name is Colleen Mckinley, and I'm the Director of Educational Partnerships and Programs at Cerritos College, where I'm fortunate to have the TRAC program. And with me this evening are two colleagues. We have Jeff Bradbury, who is a professor of chemistry at Cerritos College and also a longtime member of our TRAC leadership team, has worked with and mentored many students in our program over the years, and is also a K-12 teacher. And then also Sue Parsons, who was in my shoes before I got in my shoes. She was the original director of the TRAC program, but also math faculty. So both Sue and I come this evening with our math hats on, and are excited about talking about our love of teaching in the STEM field. So as everyone is entering, we kind of want to get a sense of who's with us this evening. If you could just type in the chat your name, what campus or organization you're here from, so where you go to school. If you're a student, just say that you're a student. If you are faculty, what your role is. So that way everybody in this community can get a sense of who's participating with us tonight. I'm going to leave that just up for a couple more minutes, and then I'm going to turn it over to Sue to talk a little bit about what this workshop's all about and what you can expect tonight. One of the things that is so great about these new opportunities for doing professional development and connecting virtually is that we would never, prior to COVID, have had this opportunity to have students from Barstow and from Cerritos College, from LA Mission College, from Palm Springs, and all of the places that you're all here from. So I think we are been trying to focus on some of the positive things that have come out of this pandemic, and this is certainly one of them. So we're glad to see you here today. Again, keep coming with your introductions in the chat, and I'm gonna stop sharing and turn this over to my colleague Sue Parsons, who is going to talk a little bit about this workshop and what we're doing here this evening.
Okay, thank you, Colleen. It's a true pleasure to be with everyone here this evening. And yes, many of you have been Zooming a lot. I've Zoomed in meetings, but this is my first, almost like a classroom experience, I think we're going to find. And as Colleen, Jeff, and I planned for this, there was really three things central to the workshop that we were thinking about. And one is adaptability, critical thinking, and the relationship between student and teachers. And I think what we're going to be doing, we will we'll be in the role of a student and in the role of a teacher as we kind of actively engage in chemistry lesson, where we're going to confront some misconceptions and some concepts related to gases this evening. That's our topic. But we're going to confront some things that are big ideas. There are tensions around direct instruction and inquiry approach, valuing the balance and the importance of both teaching and learning. So we're going to continue to talk about that as we go on. We're going to model for you, but we want to make sure that you're actively involved. And there's no person better than that than my longtime colleague and dear friend, the extraordinary chemistry professor, and most importantly, an extraordinary human being, Jeff Bradbury. And I'm going to turn it over to Jeff now, even though math rules, Jeff.
I'll never live up to that. Well, so I teach chemistry, which is very hands-on. We want our students to have as much hands-on experience as possible. And now we're in COVID, and we can't do that. So what are we going to do? So I'm trying to come up with ways to engage the students. It's kind of like if you're a PE teacher, you could have your students learn about basketball, but it's a much different thing for them to actually play it. And when it comes to science, we don't want the students just to learn about science. We want them to become scientists. We want them to think like scientists. We want them to develop the skills of science. And that's what I want to do in my chemistry classroom. But how do I do that during COVID when we're stuck at home? So this whole workshop is about thinking outside the box and trying to make lemonade out of lemons, if you will. And I want to reiterate the values that Sue mentioned. One is the relationship between the teacher and the student. We want to maintain that. How do we do that over Zoom? We're going to try to show you a little bit about that. And then the other is, how do we teach the students to actually think like scientists and be scientists? So we're going to just show you some examples. And I'm going to start right here. Sometimes I like to have hot tea, you know, which is all chemistry, of course. And so I've been boiling some water. And now pay attention. So I have a water bottle here. I still can't figure out how to line up with the camera. Pour some boiling water into, hopefully, just a little bit. Now these bottles don't melt. Okay, so do you see what's happening to the bottle? So this is what will happen after, about say 5 or 10 minutes. Do you see that? It didn't melt. So why did that happen? What's going on here? So we can still engage the students. We can make them think, and we can give them some opportunities to test their ideas. And we're going to do that with you tonight. And so we're going to put you in a little bit into breakout rooms, and we're going to try a simulation. So let me just show you. This is in your handout.
Good questions in the chat already, Jeff.
Ah, very good. Those are beautiful questions. So I'm going to show you a simulation. And we're actually going to play around with this in groups tonight. And so if you take a look at this, the link is in the handout. So watch what happens. So you can see that the gas molecules, we can adjust the temperature. We can change the molecules. So I'm going to let you play around with that in a minute. But we're going to put you into some breakout rooms. And so I want to go over those instructions real quick with you. Okay, so if you have the handout, or I'll go ahead and share that.
We put it in the chat too.
I'm going to be putting it in the chat. Yep.
Perfect.
Okay, so can you see where it says exploring? Am I sharing the right thing? Okay.
Yes.
That's another problem. And maybe you can hear, this is the one I just did. It's making noise. So if you hear this noise, that's my experiment. Okay. So you're going to take about 2 minutes. We're going to put you in breakout groups. And that's part of the process that we want to share with you about the relationship between the teacher and the student, because Sue, Colleen, and I are actually going to come through the breakout groups. We would love it if you would turn your camera on and we could interact with you. So you're going to try changing the volume and the pressure and the temperature and see what happens. Take about 2 minutes to do that on your own as soon as you get into the groups. And then if one person can kind of be the moderator, choose a person and then follow these instructions. Have one person read the instructions. Choose a third person that will record the answers onto the onto the handout. And again, somebody will need to share their screen to do that. Perform the simulation according to the instructions below. And discuss your answers together along the way. And we're going to be coming through and kind of helping you and talking with you about it. If you have questions, you can always, through Zoom, you can call us and we'll come to your breakout room if we're not engaged with another group. And then you're going to have about 18 minutes after you do a 2-minute explore. And then you're going to complete questions 1 through 5 together. Okay. And we'll give you about a 1-minute warning. If you've never been in Zoom before, when we close the breakout rooms, we'll give you about a 1-minute warning. Okay, so I went fast through that. So are there questions?
Jeff, do you mind if I repeat back what I think I heard you say?
Yeah, go right ahead.
And if you don't have the handout that was emailed to you, I just put a link in the chat for you to download it. So everybody should open that document, and it's going to look exactly like what Jeff is sharing on the screen here. We're going to be putting you in breakout rooms, and then we'll be following those instructions. And the link to that simulation is in the document, right, Jeff?
Yep, it's right there. You see the link.
Are there any other questions from the group before we do the breakout? Because we hate to send you to a breakout and then you are saying, you know, I don't know what to do. Somebody just said in the chat, I was here for math, not chem. And that is actually a good point, because even if you're not going to be a chemistry teacher, if you're here to be an elementary teacher, a math teacher, anything, this isn't about the content so much as how Professor Bradbury is showing you to present content and learn content from a different angle, and especially virtually. So you are all here because you're hopefully future teachers, and we really want to take take away from this workshop tonight what it will be like for you in the future, and how you design lessons that have your students exploring things that might make them learn more deeply what that content is. So yes, I agree, math rules, but keep an open mind, because it's more than just about.
Well, math is just the language of chemistry. So Maria, we're going to get some math in, I promise. I'll do my very best. And when it's 2 to 1 here, it's 2 math teachers to 1 chemist. So they'll, believe me, we'll get some math in. But we want you to think about the process. What would the student experience, and then how does the teacher create this experience for the student? So don't just, I encourage you not just to try to get the answers to the questions, but think about the questions themselves. How do you develop questions that draw the students out? And maybe you'll even come up with better questions than we're asking tonight. But that's what we would like for you to do, is just think about the process. And then also between the 3 of us, we want to have a conversation with each other, and that process between colleagues is something we want to model for you. Okay.
All right, so are we ready for the rooms?
Here goes.
Okay, so I hope you had some fun with that. Okay, so COVID doesn't have to be all bad, but I will show you that in the past, I have this device, okay, kind of similar, and you can push on it, and it's a syringe that's closed down at the bottom, and I could hand these out to my students, and then they could measure the pressure and the volume here, and they would get a graph. So here's our math person wanting to hear some math. It's an inverse relationship. As the pressure increases, the volume decreases. And then COVID hits, and how am I supposed to give these to my students? Right? I can't. So the simulations were a good thing. And what I like about the simulation is what you cannot see here are the molecules, but you could see them in the simulation. So in some ways, it's better, right? Because they're understanding the concept behind the gases. Whereas here, we don't know what's in there. We can't see anything. So I really like the simulation. And so COVID caused some good change. It made me really think outside the box. So just think about ways where we can maintain that relationship. So Sue, Colleen, and I tried to come into your breakout rooms and facilitate your learning. And the two, I don't know about Sue and Colleen, but my two breakout rooms were vastly different.
Mm-hmm.
And so you have to constantly be pivoting. But you know what? It's kind of chaotic, but it's a lot of fun. I love it when every group has different questions and they're at different levels. I love that interaction. And so I never met any of you before, but now I have this relationship with some of you through chemistry. And so that's one of the values of teaching, is we want to maintain that relationship, and we still can do that with our students. So Sue, did you have any observations?
Well, the room we were in, we had some technical difficulties, but I think that was part of our learning experience.
Mm-hmm.
We ended up doing some things together and just talking through some observations. And then the question came up, would we show this in an elementary school classroom? And I said, I don't know, would we? And what would be the value? And I think we talked about the value of, first of all, children exploring and coming up with their own observations. And sometimes we just give it to them, but to let them come up with their own observations. But I think one of the values was the frustration of working with the technology. We'll have to be honest, but I think we worked through that, and the team stuck with it, and we rallied around. So sometimes you have to do that. You start out and you have assignments and you have to switch around, right?
Yeah. So I wanted to show you this is maybe a little bit advanced, but this is a math workshop too. So I'm going to share with you some student work. So maybe you can see this graph. So this is a graph of temperature and pressure, and we were able to make different measurements of the temperature at different pressures, kind of the same way you played with it. And then we made a graph, and it shows that there's a direct relationship between pressure and temperature. But I really like Sue's point is just letting the students play with it, and maybe they might come up, just like some of you in your groups were going different directions from our little lesson. I think the students do really well when they can explore like that. And so I would say this is not a bad thing for elementary. I think fourth grade,
Fifth
probably.
grade, Sarah just shared that fifth grade, it's in the NGSS standards.
Yeah, that was when I went. I knew it was fourth or fifth that I went to when my kids were that age, and I would go do Mr. Chemistry, and we did gases.
I think with it in the math room, and Colleen, you can jump in. Times before I've given the formal lesson and allowed students to explore, they come up with more ideas and the main concepts I want them to get to than if I would have just directly said, okay, here it is. And it's so much more meaningful when you own your own information than when someone just gives it to you. So.
And then one of the groups I went into, they were having this intense argument about what caused this. So I think that you can engage your students. NGSS uses the word phenomena, something in science that's strange, that just grabs the attention of the students and adults too. I mean, I still love it, right? I mean, it's still fantastic when something this simple happens and it grabs the students' attention. And now they have to use these concepts to explain what happened here. And it's very challenging, but it's a lot of fun.
So Jeff, I think that's a great point about when you went in and you heard the discussion about that. If you had started this workshop by showing them that water bottle and saying, look, I put hot water in here and it did this and this is why it did it. There, it might have been interesting, but I don't think it's at the level of interest where you have students talking with each other about why that happened and interested in knowing if my prediction for why that happened was correct. It's almost like, your brain, as Sue was saying in the math classroom, they would come up with ideas on their own, but it's how brain theory works. It's how we as humans learn. And if we're interested in something and your brain's trying to make sense of it, then when the actual scientific explanation comes in, it's going to be that much more meaningful. But if you would have just started this with me and showed me that and explained what had happened, I would have been like, oh, okay.
No, and I've done that before, and it just was a dud. The students are just glazed over. I give the best lecture in my life, and it just doesn't engage. So I'm seeing some really good, Shaylin said questions are a great tool for learning. And Maria said engagement by sparking curiosity. I totally agree with that. So that's fantastic. You guys are going to be great teachers if you do that.
And you can, I think you never, as we continue and always are honing our skill and trying to be a better and better and better teacher, the art of questioning is in its whole self. I'm always looking, sometimes I ask a question and I think, oh, that was so clear, but it was as clear as mud. So what is the right question and how to make it clear to have people to draw out the understanding, right?
Yeah. And I think don't be afraid to learn along with the students. If they ask you questions, don't worry if you don't know the answer. Well, let's learn this together. Let's go figure this out together. That I still to this day have students that ask me, I never thought of that, so I need to go investigate it. So now we're going to
we have about 10 minutes.
Yeah, so what Sue and I and Colleen would like to do is we would like to investigate the relationship between pressure and volume. And we want you to put in the chat questions that we might ask. So you saw some questions in the handout the way we asked them. So now we want you to think like the teacher and ask some questions. So I'm going to share for a second the simulation again. And we're just going to now look at the relationship between volume and pressure. Okay, and then you guys can type questions in the chat. Now, if you have your own questions, that's fine. If you want, like, you don't understand something, if we have time at the end, maybe we can talk about those too. So, but we're kind of thinking of questions you might ask students to get them to think about the relationship between pressure and volume. Okay, so I'm going to move the handle a little bit and watch the pressure. So I'm going to cut the volume in half. Okay, you can see what happened to the pressure. Also, notice what didn't change. Okay, now I'm gonna go way bigger. Okay, so what we just want to do is we would love to walk with you through the process of asking good questions. And I'm happy to try something out. Of course, you can too. So Shaylin asks, what happens when you open the handle and let the particles out? Well, let's try it. Watch the pressure. So I'm gonna increase the pressure a lot, and then I'm gonna let them out. Watch what happens to the pressure. That was what the question was. So that might be a good question to ask students to help them explore. So I think there's questions where They're exploring type questions to guide them along, and then there's understanding level questions. So we want them to make observations and not necessarily all the time explain them, but can we lead them to observations? Okay, so I wonder how volume affects pressure, Sandra said. And I like the way you're phrasing that question. It's very much like, I wonder. You're kind of asking it like a scientist would. And I think that's a really good way to engage students instead of just asking it directly. You're kind of like, and they wonder themselves, does the teacher know? And I love that. Irene
you want
asked,
to go jump and do it. Well, when you ask it that way, I wonder, it makes it, oh, I have to see, right?
yeah, I love that. I think start every day of your class that way, Sandra. That's fantastic. Does the temperature change when you change the volume? And how does the volume affect the pressure? So you can see those are different levels of question, right? So some make you think more and some are more. Ask students, what do you think will happen to the water if I do this? I love that because, yeah, that's good. Those are really good things. So maybe you could, you're making the students model. That's what a scientist wants to do, is come up with a theory that predicts. And so what you're doing when you say, what do you think will happen when I do this, you're making them think ahead, and then it's testable. Well, let's go do it. So I love that question, Shaylin. I hope you ask lots of questions like that. Sue, should we land the plane here?
Land the plane. You want to go first or just jump in? Well, I'll jump in since you asked me to land the plane. Start to. I'm really, one of the things that I'm, the nugget is reminding me again, the art of questioning. And actually there's a book that's called The Art of Questioning. And so that might be something you can look up, everybody, because that's something as you continue to hone how to ask questions. It's a way of engaging students, but also I think, and what we found tonight is, and you've already said it, we're still learners. The teacher is still a learner. And if you ever quit learning, then you're not teaching. I think so. It's learning together too during that relationship, and the art of asking questions and keeping honing those questions. So that's one of my takeaways here this evening.
Yeah, I think I'm going to ask some of these questions. I love the way you guys are going to be really good teachers, and I love the way you ask questions like that. They're very much engaging questions. So yeah, work on that art form. So here's kind of what happened. So think of, you give your students tons of sugar right before recess and they're just bouncing off the walls. That's what I was doing when I was heating it up, okay? But notice the door to the classroom was open and the gas was escaping, okay? So now when I put the lid on, I have less gas in here than I did. And now the gas is cooling down and the molecules are slowing down and the atmosphere outside is pushing in. So it's like I let the kids out of the classroom and I slammed the door shut. Okay, and then they want back in, And so the air from the outside is crushing this while it's closed. Now, if I were to put it on the heat with the lid on, the pressure is going to increase, and yes, it will blow up and the students will want me to do that. I'm not going to do that because it would make a mess out of my office. But I just wanted to have some closure with that.
I think there were a lot of inquiring minds that were waiting for an answer to that question, including myself, because I would have never come up with that it's something from the outside.
Yeah,
To
it's
me, my
kind of,
brain always went to like what's happening on the inside.
and that's the hard part in teaching this, is it's the outside pressure that's pushing, making it smaller. Yeah, very good.
And Shaylin just observed we cannot see air, so we don't think about it, which
That's
is
true.
absolutely true.
So
Absolutely.
are there other questions you guys have in the last couple of minutes here? I know some of you are concerned about a certificate. Colleen's going to take care of that, right? So you don't have to worry about that.
Yep. So if you could please send an email to teachertrack@cerritos.edu so that we can reply to that email with your certificate. If you didn't get a chance to put your name and site in the chat, please do so before you leave. And we also have one other request because we hope to do more virtual workshops in the future. As I was saying earlier, it's amazing to see how we were able to collaborate with people up and down the state this evening in a very brief amount of time and just have a chat. And I think we're going to have so many more opportunities to do that in the future. So please complete the survey so that we can do better and better with this. As Jeff was pointing out earlier, this flip to completely online is new, and we're finding innovative ways of refining how we do that. And so this was our first attempt as educators of teachers. It took a lot of conversations ahead of time, but I enjoyed every minute of it. So I think the other component I would lend that came to mind about tonight is use your colleagues. As you become teachers, just collaborating with others is so important because you can't come up with all of those innovative questions on your own. So one way to really tap better into your students is to use all of those resources around you. And I want to thank Jeff and Sue for taking time to prepare for this and do this workshop, because I learned so much from you as well.
Thank you, Colleen. Guys, keep asking good questions. Maintain a good relationship with your students. Make them become the scientists.
So once again, thank you for attending with us this evening and being part of the Teach for LA virtual workshop series. I put a link to the survey in the chat so you can use that, or there's a, you can see it here on the screen, but it's a little bit difficult to click on that. So use the chat. It was great getting to connect with you this evening. Stay safe. Have a wonderful Thanksgiving. And we really appreciate spending some time with you tonight.
Thank you.
Thank you.